All right, so the second one I wanted to show you is running Stable Diffusion directly from Google Colab. It's the cloud environments. In case you're not familiar with Google Colab, it's a cloud environment, and the only thing that you need to have a Google account, and along with Google Drive and any other options that you see, there'll be an option for you to see that you are able to access Google Colab. But in this case, once you already created the profile with your user ID and password, you should be able to get in directly. And I'll have the link for that specific implementation of Stable Diffusion. Is called the Stable Diffusion with Diffusers, and I'll have the link in the description as well for you to access directly. Now, one other thing I should mention, that even if you're not familiar with Python or you're not familiar with Google Colab, I want you to understand that you don't have to have any coding experience. As you will see in just a moment, you should be able to run through it just fine. The only thing you need to watch for is where you're going to change some of the parameters and where you're going to change the prompt. That's all you need to worry about. But otherwise, you should be able to follow the steps one by one, and you should be able to run it. So let's do that right now together. So the first thing that we see, they do have an explanation of what this specific version is. They're saying Stable Diffusion is a text to image latent diffusion model created by the researchers and engineers from all of these entities. Now, we don't need to worry about any of that description here. What you need to do though, anytime you see that it goes back into a button with a play option there, you just have to click on that at that point. So it's saying this notebook was not authored by Google. I'll just ignore that and I'll just say run anyway. Saying notebook requires high RAM. There's a whole reason we are here in Google Colab, and I should have mentioned that earlier, that part of the reason it's easier to run in a cloud environment like Google Colab is because they're going to allow you for much more RAM than you have most likely in your laptop or your local machine. So you've got a whole bunch of processing power here. And while I was playing with some GAN based neural networks earlier, I noticed that the fastest way I can train and deploy them would be through here too. Again, that's just a side note. You don't need to worry about any of that if you're not a IT person or you don't have any coding or programming background. So let's just say okay. And the way you know it's done is when you see that it comes back with a check mark here, a green check mark right next to it. So now we know that this execution is done. So the next one that shows up is the installations. Again, I'm not going to go through any explanations. We don't even need to know that. But the only thing you need to watch for is when it's completed. It's just going through all of the installations that are required for you to run this. May take a little bit of time, but it seems like it's already done. So that's great. So then we just jump right back into the next set of commands that we need to run. So just click on that. By the way, it doesn't hurt to read if you have the time what they're explaining in simple terms. But for now, I'm just going to run. Okay, that's done. So this is where my understanding is, and this is the very first time I'm running with you guys as well, that you need to have a token that needs to be included here. So let's see how it goes. All right, so here it's asking for the token. And you need to have a Hugging Face profile created as well with your username and password. So it's fairly straightforward. I did it earlier today. So you just click on that link right on top. Okay, so this is where we come in. And if we click on that link, it should take us back to our login prompt. This is where you type in the username and password if you already have one. If you don't, you just sign up for it. And once again, it took me, I don't think, any more than a minute to get it set up. So let's just do that. Use this email address and the password. Okay, so hopefully I can log in. There we go. So the first time you come in, it's saying that you need a new token because they never issued a token. So just click on that button here, and it's asking for what's this token for. So we can type in saying that to run Stable Diffusion on Google Colab. Type in anything, I guess. And role, I'm just going to read it. I don't need to write. Generate a token. So now it's given me the token here. So the way I copy it, if you notice, either you can show the token, which I don't necessarily need to. Right next to show, you can copy the token onto the clipboard. So let's do that. It's already copied. Come back into Google Colab. Okay, so I need to paste it. I think it will need it. Okay, so here I need to log in. That's what the token is for. So it says login is successful. Your token has been saved. That's all great. And we don't worry about anything else there. So now we go back to the next step, which is this set of imports. So just click on that. All right, so it looks like there is something that didn't work, and I'm not sure what didn't work. What is that error message here? And you're not in the authorized list. Visit Hugging Face to ask for access. Okay, so I need to have an access first. I'm not sure if I got my access, but let's just try again. And the way to do it is just rerun it. So now it's running. So there's no reason to get worried. Anytime you see that there is a step that's not running properly, there's always an explanation given right below. All you have to do is just follow that instruction. If there was an access issue, request for the access. Seems like I got that access right at the bat. There was no issues at all. So now it's downloading anything and everything necessary to build the pipeline. Again, I don't want you to be caught up with all of the nifty details in terms of the programming. You can simply skip those until and unless we get an install working in our local machines. I'm thinking this may not be a bad option after all. And I know that if you have a powerful laptop or if you have a powerful machine, that should not be an issue at all. You should be able to download their multiple versions, and I'll have some links for those as well. Fairly straightforward for you to download into your local and run. As I mentioned in the introduction, my issue was because I'm running in an older laptop and it doesn't have sufficient power, input power or input GPU and RAM for it to complete my request. So I ended up getting black images, and I know that there are some workarounds for that, but even with that, it wasn't producing the result I expected. So I thought I might as well just take the easier route, which is to come here. All right, so that looks like it's completed. Took about a minute. So let's do the next step. And then we're getting closer to generating some images, and they already have some images that we can see. Now, let's see. There should be an option here for the prompt, I would imagine. Okay, so it looks like this is the prompt right on the top. We can change that right here, right now. So let's just say that I want to take the same prompt that I had before, and I'm just going to have a quick glimpse at that, my other screen, and let's see what comes out of that. Because the demo versions seems to have done a decent job. Let's see if this version is any better. So I'm just going to replace that with my own prompt. Let's see how it turns out. and it's going to save it. So in order for me to save, I'm just going to name it Tom Cruise. Just leave it at that and see what comes out of that. Okay, so now it's rendering my request. Looks like it's going pretty fast, as I mentioned before. As I've mentioned before, that because we're running on Google Colab, that's the beauty of running it in a powerful environment. And looks like it came back with one option here, so you can see that already. That's great. So now this is something that I want you to pay a little bit of attention to. It says running the above cell multiple times will give you different image every time, just as we expect. If you want more deterministic output, you can pass a random seed to the pipeline. Every time you use the same seed, you'll have the same image result. So yeah, I mean, we can ignore that for now. But by the way, that image is also saved, and you should be able to save it from here as well. Save image as, and you can save it into your local drive from that point. That's another option that I wanted you to be aware of. So let's see. We can run the next set and let's see what it does. It seems like it's trying to refine it a little bit. So let's see how it turns out. Going super fast, which is great. This is our next image, and now I like it a bit more because I finally see one of the fighter jets in the back, which would have been my original request anyway. I don't think I put it in there, but that would have been my hope to add that piece. I'm glad that they read my mind. So that's great. So now let's keep playing along. Now, the next set of steps, it's saying you can change the number of inference steps using the num inference steps argument. So there is this argument here, num inference steps. You can always change that. What does it do? In general, results are better the more steps you have. Stable Diffusion, being one of the latest models, works great with a relatively small number of steps, which is good. So we recommend to use the default of 50. So if you want faster results, you can use a smaller number. So that's great. So again, you just change the inference steps here, and that's how you generate the next image. But I'm just going to leave it to the default for this demo, and let's see how it turns out. So it's saying, finally it's saying the following cell uses the same set as before, but with fewer steps. Note how some details such as the horse's head or the helmet are less defined, realistic, and less defined than in the previous image. That's correct. So that's okay. Let's see how ours turn out because we're using fewer steps here as opposed to the previous one. Although I don't see where they put in the steps in here, but I think the default is higher. Default is 50. I think it's stated here somewhere. Yes, the default is 50. Now we're reducing it to 15. So obviously I'm not expecting a better picture, but look how fast it's going right now because you have fewer steps. But it's going to look, oh, look at that. Not looking good at all. I'm not sure if Tom Cruise is going to be happy to see this photo or even recognize himself, right? So, not unexpected. That's what they're saying. You can always play with it. So, what if we go a little higher? Let's go from 50, which is the default, we go 100, and let's see what we get. Might take a bit longer. That's okay. But I'm still seeing it going a lot faster. But I'm hoping it's going to give us a better picture now. There we go. Now you look at this one here and compare to that one. And once again, you'll notice that it changes all the time, right? Because it's not simply adding pieces, it's coming up with its own image. So I'm thinking that this one looks much better than the previous one, but let's just move on. All right, so the next step, what they're saying, and we don't necessarily have to read all of those. To generate multiple images for the same prompt, we simply use a list with the same prompt repeated several times. We'll send the list to the pipeline instead of the string we used before. Let's first write a helper function to display a grid of images. Again, we're not writing anything, we're just going to run it. Okay, that one is done. Now it's saying now we can generate a grid image once having run the pipeline with a list of three prompts. All right, so here you can see the number of images. We can change that, but for now they have it at three. And I'm going to change this description once again. And I'm going to use, as opposed to their description, which is generating three images now, as opposed to one, I'm going to use my description one more time. I hope I have it saved still. Not sure yet. Oh, it is still saved. That's great. So I just changed that. I replaced that prompt and I'm just going to run it. And one other thing I want to make you aware of that there is this runtime option here that allows you to toggle between CPU, GPU, and TPU. Now look at that. Three sets of Tom Cruise images, and just as expected, I think it's getting better because we have one row and three columns, so we get three images here. That's great. Again, you should be able to save any one of the images by save image. Okay, so that's great. So far, so good. And now here's how to generate a grid of n times m images. So what they're doing here is, I believe, again, they have the prompt here, and this is where we can change it all the time. And for the sake of time, I'm just going to keep copying the same prompt that I had. You can change the prompt to whichever one you like, but let's say we change that, and they have defined number of columns to be three and number of rows to be four. So that's how you see that there are four rows and three columns. So in essence, we're getting 12 images here, and which is great. So let's try it out. It may take a bit longer, but we'll try it out. Now that we have changed our prompt to the prompt that we want, let's see. And obviously, when you're generating 12, it's going to take a bit longer. All right, so we are back. Took a little bit of time because there are so many images that needed to be generated, but you'll notice that there should be, as we have expected, there should be how many? I think 12, and that's exactly what we got. Three columns and four rows of Tom Cruise. All right, so I'm sure that he like Tom Cruise will prefer some of the photos of his or some of the images generated of his more than the others, but this is great. This is how it's done. And once again, you can just, as you're running your own requests with all of the parameters included, you just save the image, whichever one you like, and you can save it into the download folder. Okay, so I think that pretty much is it. That's what I wanted to show you. And let's scroll down here. Okay, so how do you generate non-square images? So for this one, I don't necessarily have to bring in the same prompt. I'm just going to leave it to the defaults. What they're saying, typically it generates images of 512 by 512 as we have seen before. So it's more like a square, but it's very easy to overwrite the default height and width. And the way to do it is just by including that into this next set of instructions. They've already done it. So I'm just going to leave it at that and see. It looks like it's going to generate more like a rectangular. That's what we're expecting here. So let's see how it turns out. Okay, look at that. Just came back with a different photo. Now we are seeing the horse, but just as I expected, it's just a different photo, right? Every time you're running it, it's just coming back with a different photo. Now, that would be the extent to which I'm going to go through this demo or this video. But if you're interested to find out a bit more, and that's one of the positives of coming through this Google Colab version of Stable Diffusion, with diffusers is they provide you some of the insights, even if you are not prone to get some of the details, but it gives you some basic information as to how some of the stuff, intricate details, some of the stuff that goes into generating some of the images. So you can always go through the next set, and I'm just going to briefly state what those sections are covering. So they're talking about what stable diffusion is, what are the different components of stable diffusion. They have that nice diagram that shows how this entire process works if you're interested, ultimately generating this image. And the next one is how to write your own inference pipeline if you're curious enough. And if you have the time, you're always able to do that. But again, if you're not into coding or you don't have programming, I wouldn't even worry about any of that stuff. So if I scroll down, it goes through all of the steps and they have all the descriptions included in case you're interested. And the last thing they did, I think they decided to increase the steps for this specific photo. Okay, so they're not saying anything, but if we scroll all the way down, you'll notice that it's a quite a definition, because I think somewhere in here, and I'm not going to go through that right now, they actually increased the number of steps significantly. So, and that generated that clear, crispier image after all. So that's it. The only other thing, as I mentioned earlier, actually, there are a couple things to keep in mind. Like anything else in life, I don't necessarily think it's going to be completely free. You just create your Google account and you have the Hugging Face account, and you can come back into this once you're comfortable enough to come on a regular basis and you keep generating images. There'll be a limit. There's a limitation after which you may have to pay for the additional usage of their processing power. And the way to see what are the options here, see the runtime here right now is GPU, right? So if you click on that drop down, you'll see there's even a TPU as well. But for our purposes, GPU is more than enough. But what I'm proposing here, at some point, don't be surprised if you get notified that you need to upgrade it by purchasing a plan, which is minimal, because I had to do that while I was playing with some of the GAN based models to generate or to do some image to image translations. They're not that bad, but you may have to pay at some point, even if it's minimal. But if you're serious about it, I think this is the way to go. The way I see it, it's a whole lot easier for me to get some additional GPU processing power through Google Colab as opposed to perhaps buying a new laptop to run it locally. So that's something to keep in mind. So I'll just leave it at that. I hope that you found this tutorial just as useful. I know some of you guys are wondering what's the point for me to come in here and look at all of these codes, but I can assure you, once you know how to run them and you know some of the basics, this actually would have been the very first time I ran it with you guys, but it went quite smoothly. So I wouldn't worry too much about it at all. And that's it for now.